Hello, I welcome you all to this another interesting screencast. The problem reads: determine the force in each member of the truss and state if the members are in tension or compression. Set theta equal to 30 degrees. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. We solved a similar problem like this, and the angle in that particular problem was theta equal to 0 degrees. In this particular case, we have been told that theta is equal to 30 degrees. Okay, so let's draw the free body diagram. At the roller C, we expect a reaction force in this direction perpendicular to the surface where the roller is resting. We are calling it C. And then we are going to have two components from this. We're going to have a vertical component. This angle here is theta, which is just 30 degrees. Okay, therefore this becomes C cos 30 degrees. And then we'll have another component in this direction. This is C sine 30 degrees. So this one is equal to 0.5 C. This one, I'll just leave it the way it is because it has a number of decimals. Right. So at A, which is a hinge, we have these reaction forces. We have AY, and then we have also AX. Alright. I guess we've drawn all the reaction forces. Let me just also draw the slope. Here the slope, we expect the slope using a triangle to determine our slope. Right angle triangle. So here at the bottom we have the run of 2, we have the rise of 1.5, and 2 squared plus 1 squared, 2 squared plus 1 squared, and then root of 6.25, we get a 2.5. The slope also this side is the same. The slope is the same this side. This right angled triangle. So we'll have the run of 2, the rise of 1.5, and the hypotenuse of 2.5. Alright, so let's apply the equations of equilibrium quickly so that we find all these values. So start with applying summation of moments about point A equal to 0, and clockwise being our reference. What do we have? We have a minus 4 by 2, and then we have a minus 3 by 1.5. Then we have a plus C cos 30 times 4. Yes, that's about it, equal to 0. Therefore C will be equal to it's minus 4 by 2 minus 3 by 1.5 divided by 4 cos 30, right? 4 cos 30. So this gives us a 3.6084. Okay, let me just check it again. Minus 4 by 2 minus 3 by 1.5 divided by 4 cos 30. Yes, 3.6084. Great. And then we have summation of forces in the y direction. Okay, what do we have? We have AY minus 4 plus C cos 30 C cos 30 is equal to 0. And therefore, AY is going to be equal to, having in mind that C is already calculated, therefore we replace it as shown. So this will give us 3.6084 minus 4 plus 3.6084 cos 30. It gives us 0.8750 kilonewtons. So minus 4 plus C, which is 3.6084 cos 30 0.8750. Okay, and then we have summation of forces in the x direction equal to 0. What do we have? We have ax plus 3 minus 0.5 c. This c sine 30. Okay, we already have what c is. We just replace c. Okay, therefore we have ax equal to, so we have 3 minus 0.5 times c, which is 3.1684. So ax is equal to minus 1.195 1.1958 kilonewtons. Right, so we found all the support reactions. Let's replace them here. We have ax equal to, let's change the sign. The sign for ax is this side. So this is 1.1958 kilonewtons. Ay is equal to 0.8750, and C is equal to 3.6084 kilonewtons. Right. So let's start with joint joint A. So joint A. Okay. So what do we have? We have a 1.1958. And then we have 0.8750. Let's say this one is in tension AB, and then let's say this one is in compression with the slope already indicated in the diagram. We call it AD. So let's find these components. So this one is going to be equal to AD by the run 2 divided by 2.5, and then we have, this one AD, okay, by 2 divided by 2.5. They are supposed to point inwards. Then the other one is AD by 1.5 divided by 2.5. Great. So we have everything. Let's apply the equations of equilibrium. Let's start with y. So summation of forces in the y equal to 0. What do we have? we have 0.8750 minus AD by 1.5 divided by 2.5 equal to 0. Therefore, AD is just going to be equal to, grab your calculator, so 0.8750 divided by 1.5 divided by 2.5. Okay, so AD is equal to 1.4583 kilonewtons. Okay, 0.8750 divided by 1.5 divided by 2.5, 1.4583. Right, then we have summation of forces in the x direction. What do we have? We have minus 1.1958 plus AB, and minus AD2 divided by 2.25. Alright, we've already calculated what AD is, so we can replace it there. When we do so, we'll find that our AB is going to be equal to, let's calculate it, minus 1.1958 minus AD, which is 1.4583 times 2 divided by 2.5. Alright, therefore AB is equal to 2.3624 kilonewtons, and AB we are assuming it to be in tension, and therefore it is. Okay, let me just check it again. 1.1958 minus 1.4583 times 2 divided by 2.5, so 2.3624. Great. So found this, let's go to another joint, which is joint B. Okay, joint B, there we go. This was what? This was A. This is joint B. Okay, what do we have? We have a force down of 4 kilonewtons. We have a tension force this side that we calculated, which is AB. So this is a 2.3624. Then we have a tension force up, which we'll call BD. And then we have another tension there. So this one we can call it BC. Alright. So we have summation of forces in the y equal to 0. Okay. What do we have? We have BD minus 4 equal to 0. Therefore, our BD will be equal to 4 kilonewtons, and this will be in tension. And then we have summation of forces in the x direction. What do we have? We have minus 2.3624 plus BC equal to 0. And therefore our BC will be equal to 2.3624 kilonewtons, and this one is also in tension, right? Okay, let's go to another joint, which is joint C. Alright, there we go. So this is our joint C. What do we have? We have a tension force this side, tension force of We calculated this already. This tension force. This is a tension force which is BC, so this is 2.3624. And then we have another force this direction, which is 0.5 C. Okay, 0.5 C, which is equal to 0.5 C, and is equal to 0.5 times C. What is our C? Our C is 3.6084. So this is equal to 1.8042. And then we do have another force. This one is C cos 30, and this is equal to 3.684 cos 30. It gives us a 3.1250. Great. And then let's say this one is in compression. Okay, and it has the slope that we've already determined in the figure, and this one you are calling it CD. And CD will have some component. It will have one component this side, so this will be CD times the run divided by the hypotenuse. Okay, and then we'll have another component there, which is CD times the rise divided by the hypotenuse. Great. So let's find CD. Let's apply just the summation of forces in the y. That will be enough. Summation of forces in the y direction going up in our reference. What do we have? We have 3.1250 minus CD by 1.5 divided by 2.5 equal to 0. And therefore, our CD is going to be equal to 3.1250 divided by 1.5 divided by 2.5. Great. So this one is equal to 5.2083. Okay, kilonewtons, and this is in compression, right? So 3.450 divided by 1.5 divided by 2.5, 5.2083. So we have found all of them, right? Yes. Let's just outline them. We have CD. And it's in compression. Okay. We have BC and it is in tension. And then we have BD and it is in tension. Okay. And then you have AB and it is in tension, right? And then finally we have AD. What did we say? AD is in compression. Alright, let's outline it also. So AD is in compression. Great. So I think this is about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.